And this is one of the biggest mistakes I see a lot of people, even pro users, making. So unless you can pinpoint exactly where in your code and you can say, Chris, this is exactly why I made this decision, you probably made the wrong call for your project or you started way too deep in over your head. So today we're going to be talking about Conan layouts and project structures. This is one of the most common mistakes that I see people making. Even pro users, you'll see them recommend using a Conan recipe, the Conan file.py extension, even for the most basic and simple of cases. And this really sets you up to make a lot of mistakes. So right now, the general default advice, even for pro users, you should probably be starting with a Conan file.txt, simply trying to consume your dependencies and building your project without Conan, just purely using CMake or Bazel or your own build scripts, should work first. Then you can add Conan. Then you can upgrade to the Conan file.py. So we're going to go over a few examples, and I'm going to share with you why you've probably made these mistakes yourself. So the best example is our new blog post for SDL, getting into game development. And you can see here, this project is actually really simple. We have a source folder. This is going to contain our source code. This is a small application, so there's no includes, not a library exposing anything. We have a CMake list.txt. We have a Conan file.txt. And we have a run example. This is what we use to run our CI/CD scripts. And you notice here, this is only using a Conan file.txt. Because when you make a small game application, this is something that you're not going to necessarily need to package and deploy and reuse in other packages, right? And that key level of using this in other packages, once you start becoming a producer for packages, that's when you should get into the Conan recipes. But for most cases, a great example of this app, you just need a Conan file.txt. You can see here we have a require statement. We're going to be using STL, hence the name of the blog. And we're going to be using some generators, CMake toolchain and CMake deps. All of these you can call from the command line with a zero exception. And we're going to find a layout, CMake. It's quite easy like that. And being able to consume recipes in this manner is where you should be starting trying to build your project. So when you look at the Conan file.list, this is also exceptionally easy. We're talking 20 lines of code. Most build scripts, and if you watch like a best practices for CMake, they're really focusing on the producer side, and those examples are way more complicated. So this just simply pulls in those dependencies and makes sure we can build our application. And that's the starting point. That's the default advice, where if you're not starting at this point, you're probably doing too much to begin with. And to show this off, I have one of our older blogs that we recently updated for Imigu, another UI application. And you'll notice this one's a little bit more complicated. However, this is also only making an application. So if we look at our CMake list.txt, we're only doing add executable. There's no library here that's being packaged that needs to be redistributed. It's a simple, small demonstration application. But you can see here, this one used a Conan file.txt. And because of this, it needed to do a lot of things. The reason this makes sense though, is because here there's a generate method, right? So this is an example of why you needed to use a recipe. This one here is, it needs to copy different dependency files out of the package folders into the bindings so that they can work correctly because of how Imigu loads all the different dependencies. All right. And if we go back to our original starting point, you could see here, this is a project that I build and package. However, it wasn't until I actually needed to use a layout where I decided to actually upgrade to using a recipe. Because I'm using a monorepo where there's multiple different points, this one in particular has the API in a parent folder that we need to access for these schemas. Regardless of that though, this probably didn't need to actually be a recipe. So this was the coup de grace, that moment of realization where like, oh yeah, this project actually deserves its own recipe. So what does a good example project actually look like? That's what I have here for you right now. So if we take a look at this example, what we're going to be showing off is a quick little hello world example. So you can see here the setup and instructions are very simple. It shouldn't really be confusing to anybody. This is going to be using a Conan file.txt. So you can notice here we're going to be having our requirements. This is a hello world, right? So it's going to be using FMT. This is the version range syntax. You should use version ranges. It's one of the easiest ways to make things compatible and to solve version conflicts. Right? For our generators, these are standard for the CMake. This is the CMake toolchain and the CMake depths. And lastly, we have our layout CMake because this is going to be a CMake based example. Next up, we have our lock file. So using recipe revisions, regardless of whether you're using Conan 1.x or 2.0, is highly recommended. So you can see here, despite us using a version range, we're going to have an exact pinned down version. So the version range here with this little caret means this is version 10 for any minor or patch version. So whether that be 10.1.0, 10.0.1, but 11 or 9 wouldn't be a valid version range for this. All right, and we can see this here being satisfied with our version range. This is a CMake project. So here is the minimal example that you need as a consumer to build your project. There's a lot of CMake best practices out there where they go off into a lot of details that make very complicated ones. You don't need to. A simple call to find package with the FMT library we're going to be using. We have our add executable, and this is just going to be linking against our main.cpp in our source folder, right? And this is where I have my source code. Very simple, hello world. And we're going to be linking against FMT. And for this example, we're going to be compiling with C++14, just to keep things interesting. Next up, you're going to notice we have our conan.rc file. So this file allows us to give Conan from our current working directory, so from our project folder, a new cache. And the best practice that I'm going to put forward for you guys is to use the cache in your current project folder. This makes it really easy to work with, and it avoids a lot of the problems where people get confused about where their cache is, what global files they're using. When you have to clear things or change things, it makes it a lot easier to work with when you only have to reason about this exact project. And lastly, you'll notice we have a .conan file with some profiles, and this is going to be C++14. That's what we're going to be compiling our project with. And you can see here we have a CMake generator for Ninja. So it's a very easy thing. If you wanted to make this a little bit more complicated, you could add your CMake and Ninja as tool requires to your profile or to your build requirements, depending on how you want to set that up. And that would be totally viable. So what we're going to do is we're going to do a Conan profile detect. And this will help set up all of our Conan cache. So you can see here we now have a new .conan2. We got settings, version, our extensions, and when I do Conan config install, you'll now notice we have a new folder, profiles, and that's going to be our C++14 alongside of our default. So all we have to do is Conan install build missing, and we're going to be specifying our profile for that C++14 config we want to be doing. FMT does not exist for Apple Client 14 on Conan Center, so I have to build it locally, which is what you're seeing happening right now. Then all you have to do is run our CMake configure command, which is going to be right over here. This will configure CMake, and then all we have to do is add --build without a space because that's a typo. And this will build our project. So we can then do build, release, and then we called it hello world example. And if my CPU was less busy, we'd get hello world. So that's it. It's as simple as that. So if you're making a pure consumer project, this is the project folder that I would really recommend you starting with. Even if you're trying to get into building and packaging your own libraries to be used within a Conan graph, this is the right place to start. A lot of people make the mistake of, I'm going to start off with the packaging and worrying about the CMake install before they even worry about, can I build my project with CMake as it is? So regardless of how you get your dependencies, because this CMake script doesn't say anything about Conan. So you can install FMT without Conan, and this should work. So adding Conan isn't making your Conan file or your project more complicated. It's just using good CMake and best practices that are already there and doubling down on those. If you think you know a better way, or you have a different way you'd like to show off and share, leave a comment down below. Hit that like button, and don't forget to subscribe.